It's good to be back here in Rome and at FAO. My doctorate is in agricultural and environmental systems. But equally importantly, I'm a farmer. I've been an organic farmer for more than 50 years, and I'm still a farmer, and I produce commercial quantities of organic fruit. In fact, many tons every year without using any toxic synthetic pesticides. On top of that, I have had experiences in farming systems in more than 100 countries. One of the major issues in this meeting, this United Nations meeting, is about banning chlorpyrifos. So I'd like to start with that. And particularly, the really important issue is that the scientific research shows that the smallest amounts of pesticides affect the normal development of the nervous system in the fetus and children. And this is because the developing fetus and children do not have the same detoxifying liver enzymes that we have as adults. Therefore, they have the inability to detoxify the smallest amount of pesticides. And the research shows that there is no safe level of these pesticides for these age groups. There are multiple studies that show that the smallest amounts of organophosphate pesticides, of which chlorpyrifos is in this family, cause damage to the development of the brain, of the nervous system. The brain is the biggest collection of nerves, and what these studies show that it affects the development of the brain and consequently reduces the IQ of children who have been exposed to the smallest amounts. There are multiple studies looking at chlorpyrifos, and one of the most important shows that exposure to amounts of chlorpyrifos way below what is regarded as scientifically safe cause measurable brain damage. This is MRI scans, pictures of MRI scans of the brains of children. And these show the areas that have been damaged by their mother's exposure to the normal residues of chlorpyrifos. These are the amounts of chlorpyrifos that are found in food that the regulatory authorities say are safe. These mothers ate the normal American diet. They thought they were being healthy by eating fresh fruit and vegetables, but unfortunately, because of the nature of these pesticides, the more fresh fruit and vegetables that people eat with these pesticides, the worse the damage is for their children. And this study alone should be enough for this toxic chemical to be banned. However, very importantly, I want to say there is no need for these toxic chemicals in agriculture. We have very good science showing that soil health can solve up to 80 to 90% of pest and disease problems. And this is because most pests and diseases are opportunistic. They attack plants that are stressed. And healthy plants put out a range of compounds to protect themselves from pests and diseases. The science shows that correctly balanced soils ensures that healthy plants have minimal disease and insect damage. This is an example. This is a field trial, and it's the same soil, the same variety of wheat that is being grown there. There's the same level of fungal spores that cause rust. However, the wheat that's been grown with compost, and this is compost made by farmers on their farms, does not have rust, whereas the field that's been grown with synthetic chemical fertilizers and it's been supervised by agronomists from the local universities has been badly affected by the rust and needed to be sprayed with fungicides, otherwise they wouldn't get any yield. And despite spraying it with fungicides, the wheat grown with the synthetic fertilizers, it only achieved 1.6 tons a hectare. On the other hand, the wheat grown with compost resisted the rust and yielded over 6.5 tons per hectare. And this is because compost is not just a fertilizer, it is a complex inoculant of millions of species for the soil microbiome that protects host plants from pests and diseases. This is a very good long-term scientific trial. It was published as a peer-reviewed study by the United Nations Food and Agriculture Organization, and it looked at over 900 samples over 5 years. So there's a high level of confidence in the study. And what it showed is that the crops grown with compost had more than double the yield, more than 100% increase in yields over the traditional systems. The green bar is the compost. The smallest bar on the left-hand side is traditional system, and the bar on the right-hand side of the compost are the trials that were supervised by agronomists and grown with chemical fertilizers. In every case, the compost had higher yields than the chemical fertilizers. This is good evidence-based science showing how soil health increases yields and reduces the need for pesticides. This is a picture of a papaya, and in Australia, papaya and many other crops get attacked by a very devastating pest called the fruit spotting bug. And for many, many decades, Australian farmers fought to keep endosulfan, stating it was the only pesticide that kills fruit spotting bugs. And they used the worn-out mantra, we will lose our crops without it. Australia was the second last country to ban endosulfan. And despite years and years, actually decades of saying, oh, we need it, we'll lose crops, when it was banned, no crops were lost. And this is always the case. There's always this thing, oh, we have to keep the pesticides, we'll lose production, we'll lose costs. Every time they're banned, there's no evidence of loss of crops because there are always better ways than using synthetic pesticides. This is a picture of papaya on my farm. I'm a commercial grower. And the bottom part of it, you can see the damage done by the fruit spotting bug. In fact, it will kill papayas if it's not controlled. And then you look above the arrow and you can see that the papaya is clean. There's no damage. You can see the fruits being set. I didn't spray anything. I just fixed up the soil health. And once you improve the soil health, healthy plants put out protective compounds. We have very good science on this. In this case, the protective compounds, they don't kill the pest. They make it sick. They slow it down. And this enables the beneficial species the chance to easily find it and basically use it as food. So here's pictures of multiple beneficial species that we have in farms, such as hoverflies, ants, little birds, frogs, spiders. The picture at the top are the eggs of a parasitic wasp that's been laid on a caterpillar. The wasp stings the caterpillar, paralyzes it, and the eggs then lays the eggs for its young to eat. The really important thing here is when we spray synthetic fertilizers, so when we spray synthetic pesticides and chemical fertilizers, we kill beneficial species. And this locks farmers into perpetual spraying of pesticides. The better thing to do is to use agroecology and change our farms, bring in functional biodiversity, the host plants for the beneficial species. Some of the most important are flowers, because a lot of these beneficial species, such as parasitic wasps, hoverflies, lacewings, have carnivorous larvae that eat the pests. However, the adults need nectar and pollen. And if you see in these pictures, you can see the parasitoids, the little wasps here. They're feeding on nectar and pollen. They use it as food source. It's rich in sugars and rich in protein, but also they put out these parahormones, these compounds that they need to become sexually active and reproduce. And when they reproduce, the female will then lay her eggs. She'll sting the caterpillar here, it paralyzes it, lays her eggs in the caterpillar, and then when her babies hatch, the larvae, they will feed on the caterpillar and emerge. And that way they will control the pests, but also we get more parasitic wasps. But if we don't have flowers, those larvae cannot develop into adults, and we break the whole reproductive cycle. So it's essential that we introduce flowers into our farming systems, because they provide nectar, pollen, mating sites, and refuges for beneficial insects. This is a picture of our farm. I've used a high contrast pictures here because I wanted people to see the effect of what we're doing here is using sunlight to provide multiple ecosystem services. The flowers in this system host beneficial species. They are what we call insectivories. But there are other ecosystem functions in this. The root exudates from these ground covers, these cover crops, build soil fertility and soil health. Using legumes means that we get all our nitrogen for free. We don't have to use nitrogen fertilizers. They suppress unwanted plants, weeds that we don't want, gives us pest control. Very importantly, it shades the ground to reduce evaporation. We call this a living mulch, and it cools the soil by stopping direct sunlight. So it makes a big difference. The soil doesn't get overheated, so the roots can grow without being damaged. Really importantly, we increase the efficiency of the farm by capturing the sunlight not used by the cash crop. This system provides multiple ecosystem functions that are powered by solar energy. There are other ways of managing our crops by providing insectivories. And one of the most important ways is called strip mowing. And if you look at this picture, you can see the difference in the amount of beneficial species, the natural enemies of our pests. There's more predatory spiders, more predatory bugs, parasitic wasps, lady beetles, and lacewings. And this is how We do it on our farm. We mow in strips and leave areas of insectaries where we've got a high diversity of plants, of flowering plants, and we mow it in stages. So where you can see the insectary on the top picture, at some point that will be mowed down, but there'll be other areas that have grown up with the flowers. On the bottom picture, you can see an insectary that essentially we grew over our rainy season. And next to it is one of our crops called the lychees. And when they flower, that's the time we need to protect them from pests, because if the pests eat the flowers, we do not get fruit. So what we do with this insectary is we slowly strip mow it. We do it in stages. And each time we mow a strip, that forces the beneficials out into the flowers to control the pests. So this way we can manage our pest control of our flowers at critical times. We can time it and have control over the system so that we get very good fruit set without pest damage. There are other ways of doing this, and this is a very good system called push-pull. It's used to control stem borer in maize. Maize is the most important food crop in the planet. It's the #1 crop in the whole of the Americas, and it's the #1 in Africa. In Asia, it's the #2 after rice. And everywhere maize is grown, it gets attacked by stem borers. And normally this is treated by spraying toxic pesticides, or lately by having genetically modified plants that actually put out toxic poisons. In this case, instead of doing that, we add functional biodiversity. It's a plant called Desmodium, and Desmodium puts out protective compounds that repels the stem borer moth. In this system, as well as having the Desmodium that repels the moth, we have what's called a trap crop that the moth prefers. So the moth will lay its eggs here, and this is called Napier grass. There's a range of other grasses we can use. You have sharp silica hairs and also sticky exudates. The moth will lay its eggs here. The eggs hatch, little caterpillars get caught up in the sticky exudates, and the sharp silica hairs, silica is glass, cuts the caterpillars and kills them and breaks the cycle. Similarly, Desmodium puts out another range of compounds that causes the suicidal germination of weed seeds. So here you can see an example. The traditional system, this is in Africa, it's a parasitic weed called striga, and also the damage that gets done by the corn borer. So the traditional system is very low yielding. Just by adding Desmodium, control the striga, the main parasitic weed, and it controls the stem borer. So you can get up to 10 times the traditional yield by adding this functional biodiversity. This system now has been applied to all different sorts of crops. You can use it on every grain. Here you can see it used in chili. They've got it in the chili, and then the border of the chili, the Napier grass. This is a mango orchard. You actually have the Napier grass and the Desmodium in here, and also they use alfalfa, which is a very good insectary plant as well, and they get perfect mangoes without any damage. There are sometimes the need for sprays, particularly when farmers are starting to set up these ecological systems. It takes time to grow all the host plants, to build up all the beneficials and get the ecology. In that time, people will need a way to protect their crops. What we'd like to say is that spraying pesticides and fungicides should be regarded as the tools of last resort, not the tools of first resort. That's the way that they're used in industrial agriculture. In fact, they're actually used as the tools of only resort. They don't use ecological systems. We like to say that ecological systems and soil health are the first and the primary ways to control pests and diseases. And then as a backup, you can use spray management. The best sprays to use are completely non-toxic, things like edible vegetable oils, flour and water, mild soap, clay and water. These are completely non-toxic. No one is going to get sick from it. They don't poison the insect. They just smother them. Insects have these very small little breathing pores, and these block them and cause the insects to basically suffocate. There are a range of natural minerals like sulfur, copper sulfate, baking soda that can be used as fungicides, miticides. These are all natural and used properly do not cause any problems whatsoever. Also, essential oils is a range of what we call botanical pesticides that come from plants. And essential oils such as eucalyptus oil or lavender oil is a whole range of these oils can make very useful pesticides and fungicides. The most powerful is called natural pyrethrum. It comes from the chrysanthemum. It's been used actually for thousands of years. The Chinese have been using it traditionally. And natural pyrethrums, it's here the word is plural, pyrethrums. It's not one. It's a mixture of multiple pyrethrums. And every year, to stop the insects from becoming resistant to it, the chrysanthemums change the mixture of pyrethrums. So as the insect starts to get resistant to one batch, the next batch is different. And so there's no insect that is resistant to natural pyrethrums. So it will control everyone. The other really important thing is without having the synthetic synergist, piperonal butoxide, which is very toxic, it should not be used. But just using natural pyrethrums, there's no residues after 48 hours. It just breaks down and there's nothing on the food, nothing to harm the environment. There's a lot of biological pesticides, and these are specific to the pests. So, for instance, Bacillus thuringiensis valkostaki just controls caterpillars, doesn't kill anything else. This is a list of some of them. There are many of them. They're very effective. Apart from the biologicals, which will only kill the pest, all the others are broad spectrum. They will kill all the insects, and that includes the beneficial insects. So never do a complete cover spray over the crop, because you'll kill the beneficials. And once you do that, farmers are locked into endless losing spray battles because they have no beneficials, no natural enemies to control their pests. So there's a very good IPM technique called hotspot spray. And that is because the pests aren't evenly distributed over the crop. They're in clusters. We call these hotspots. Just monitor it, the crop, find out where these hotspots are, and just spray these areas. Leave all the other areas alone. That way you don't kill all the beneficials, and the beneficials in those areas then will control the remaining pests. And that way you can ensure that you have a healthy population of beneficial species. And lastly, I want to end with this and say that toxic synthetic pesticides are not needed. Last year, the Rodale Institute published its 40-year report on its farming systems trial. And they showed that the regenerative organic fields had higher yields than the industrial agriculture systems that use synthetic pesticides and fertilizers. In fact, on every criteria that they analyzed, the regenerative organic was better. So this shows that we have the science and the evidence that by scaling up these systems, there is no need for any synthetic toxic pesticide or fertilizer in farming whatsoever. And this should be our priority. We should be scaling up these systems and banning every single toxic synthetic pesticide. Thank you.